Your F-150 has a series of factory settings baked straight into its electronic control units that are quietly grinding your engine bearings to dust, cooking your transmission fluid, and starving your timing chain for protection. Most owners have no idea because the instrument cluster tells you everything is running at optimal temperature, while microscopic metal flakes are already circulating through your galleys. Today, I am exposing 5 factory settings that are destroying your truck without you knowing. Setting number 3 has caused more catastrophic bottom-end failures than any defective part Ford ever bolted onto an assembly line. And setting number 1 is so deceptive that owners actually think it is saving them fuel when it is doing the exact opposite. Let's get into it. Setting 5. The Factory Electronic Throttle Response Map. Ford programs your accelerator pedal with an aggressive delay curve in the lower 20% of travel to smooth out emissions testing cycles and artificially boost EPA fuel economy ratings. When you step on the pedal from a dead stop, you think you are feeding the engine throttle, but the computer is deliberately holding the butterfly valve closed for up to 400 milliseconds, while it enriches the fuel mixture to burn off hydrocarbons. Here is why that causes damage. That half-second lag forces you to press deeper into the pedal to get the truck moving, which instantly triggers an abrupt, jerky downshift in your 10-speed automatic transmission under load. I have pulled transmission oil samples from trucks with under 40,000 miles that show excessive clutch material, suspension, simply because the valve body is constantly slamming clutches together to compensate for dead pedal travel. The constant shock loading shears the molecular bonds of the Mercon ULV fluid, dropping its viscosity index below operational thresholds and leaving your planetary gears unprotected. The solution is free and requires 0 parts. Stop accepting the factory lag. Go to an authorized tuner or use a quality OBD2 programmer to flash a linear throttle response map that eliminates the dead zone, matches pedal input directly to throttle position, and lets your transmission engage smoothly without the abrupt torque spikes that destroy internal clutches. Setting 4 is one that Ford markets as an advanced fuel-saving feature. But under certain driving conditions, it is creating the exact environment that destroys your valve train. Active cylinder management, or variable displacement, shuts down cylinders 4, 5, and 8 by collapsing the hydraulic lifters whenever you are cruising on the highway under light load. Ford claims this saves up to 7% on your fuel bill over the course of a tank. What Ford fails to mention is the hydraulic pressure drop that occurs in the oil galleries feeding those specific lifters when the computer commands them to deactivate. At highway speeds, oil temperature routinely hits 220 degrees Fahrenheit, which thins out your factory 5W30 oil. When the solenoids command the pins to lock and unlock the lifter plungers thousands of times during a single road trip, the momentary pressure starvation causes micro-scuffing on the roller bearings and the camshaft lobes. I have personally inspected rod bearings and cam lobes out of Coyote and EcoBoost engines where the cylinder deactivation lifters seized solid, galling the camshaft into scrap metal because the needle bearings disintegrated from lack of localized pressure. The damage accumulates silently over tens of thousands of hours until you get a violent misfire code and a 4-figure repair bill. The solution is simple. If you have a tuner that allows you to disable cylinder deactivation, turn it off permanently, or make it a habit to drive in tow haul mode on the highway, which automatically locks out cylinder deactivation entirely and keeps oil pressure steady across all 8 cylinders. Setting 3. The Factory Adaptive Transmission Shift Schedule and Thermal Bypass Valve Operation. Ford programs your 10-speed transmission to aggressively upshift into the highest possible gear by 40 miles per hour to eke out fractional gains in EPA fuel economy, keeping your engine lugging at a miserable 1,200 revolutions per minute under a load. At the same time, the factory thermal bypass valve is designed to keep transmission fluid locked out from the external cooler until the fluid temperature hits a staggering 206 degrees Fahrenheit. Here is the mechanical reality that destroys your transmission from the inside out. Lugging an engine at 1,200 revolutions per minute while asking it to pull a 2-ton truck up a grade creates massive combustion chamber pressures that push past the piston rings, dumping unburnt fuel into your crankcase and diluting your oil. Simultaneously, trapping transmission fluid until it crosses 200 degrees bakes the friction plates, hardens the valve body seals, and turns your fluid into dark varnish. I have pulled transmission valve bodies apart where the plastic accumulator pistons were literally warped and melted from sustained heat soak because the factory thermal valve refused to open during normal highway cruising. The solenoids get gummed up with cooked fluid debris, leading to harsh 3 to 5 shifts, delayed engagement into reverse, and eventually, catastrophic planetary gear failure, where the sun gear strips its splines clean off. The solution does not require a $4,000 transmission rebuild. Stop letting the truck lug itself to death in economy mode. Make it a habit to drop the transmission down a gear or two manually when city driving, or drive exclusively in tow haul mode during your daily commute to keep your RPMs in the sweet spot between 1800 and 2200, where the oil pump actually flows enough volume to keep things cool. Furthermore, if you are out of warranty, replace that restrictive factory thermal bypass valve with an upgraded aftermarket thermal bypass pellet that lets fluid flow to the cooler at 160 degrees instead of cooking your transmission at 206. Setting 2. The factory aggressive battery charging profile and smart alternator management system. Ford's powertrain control module utilizes a current sensor on the negative battery terminal to constantly monitor your state of charge, deliberately dropping alternator output to 0% during deceleration and light cruising to reduce parasitic drag on the crankshaft and squeeze out another 1/10 of a mile per gallon. The factory computer keeps your AGM battery floating at a chronically undercharged state of roughly 80% capacity to maximize this fuel-saving buffer. What Ford does not tell you is what happens to your electrical accessories, your starter motor, and your battery chemistry when you live in a constant state of partial charge. AGM batteries rely on a full absorption charge cycle to prevent sulfation on the lead plates. By starving the battery of consistent voltage and cycling it between 80 and 90% charge thousands of times, lead sulfate crystals harden permanently on the plates, destroying the battery capacity within 3 years. Worse yet, when you demand massive electrical draw for your fuel pumps, ignition coils, and cooling fans, while the alternator is commanded off to save fuel, the system voltage sags below 12 volts. That low voltage condition forces your high amperage fuel pump drivers and starter solenoid contacts to pull double the current, creating extreme heat that melts wiring harness connectors, burns out starter windings, and fries the integrated voltage regulator inside the alternator itself. I have diagnosed countless no-start conditions on late-model F-150s where the owner thought they just had a bad battery, only to find the entire main power distribution fuse box melted because the computer was artificially starving the electrical system of steady voltage. The solution is entirely behavioral and preventive. Stop letting the truck's smart charging system manage your battery into an early grave. If your truck sits for a couple of days between drives, hook it up to a smart maintainer to force a complete absorption cycle and break down those sulfate crystals before they permanently kill the cells. When you replace your battery, always perform a battery monitor system reset procedure through an OBD tool or the specific ignition key dance, so the computer stops treating your brand new battery like a 5-year-old depleted unit. Setting 1. The factory ultra-low tension piston ring and extended oil change interval programming. This is the single most destructive, financially devastating factory setting programmed into your F-150's powertrain control module, and dealerships actively lie to your face about it. To meet tightening corporate average fuel economy standards, Ford's engineers designed modern EcoBoost and Coyote engines with ultra-low tension oil control rings and programmed the oil life monitor to greenlight 10,000-mile change intervals based on an algorithm that assumes ideal laboratory driving conditions. Here is the mechanical nightmare that unfolds inside your engine block while you trust that dashboard percentage. Low-tension piston rings are designed to minimize friction against the cylinder wall, which sounds great on a marketing brochure. But when you combine those weak rings with a 10,000-mile oil change interval, the oil breaks down, loses its shear strength, and allows unburnt fuel and carbon blow-by to pass the rings into the crankcase. That fuel dilutes your oil, turning what should be a protective lubricant into thin, black solvent. At the same time, the extreme heat cycles inside the turbochargers and combustion chambers bake that oil into a hard, carbonaceous lacquer inside the ring lands. The oil control rings stick completely solid in their grooves, losing their ability to scrape oil off the cylinder walls. Once those rings stick, oil consumption skyrockets to a quart every 1,000 miles. But it does not stop at oil loss. That unsealed combustion chamber lets superheated exhaust gases blow straight down past the piston, cooking your wrist pin bearings, scoring your cylinder walls with deep vertical gouges, and filling your intake manifold with a sludgy cocktail of burnt oil vapor through the positive crankcase ventilation system. I have torn down engines with less than 60,000 miles where the cylinder walls were completely ruined, requiring a $10,000 short block replacement. All because the owner followed Ford's recommended 10,000-mile oil change schedule. The engine literally drank itself to death from the inside out, while the oil life monitor still showed 20% remaining. The solution is non-negotiable if you want your truck to last past 150,000 miles. Throw away the factory 10,000-mile oil change interval right now. Change your engine oil and filter every 5,000 miles without exception. Use a high-quality, full synthetic oil that meets Ford's exact Ford WSSM 2C 947 or 961 specifications, and check your oil level every single time you fill up your gas tank. Stopping oil dilution and keeping fresh additives in your crankcase is the only way to prevent those low-tension rings from sticking and saving your block from catastrophic scoring. The thread running through every single one of these factory settings is simple. Manufacturers build these trucks to pass government regulatory tests and survive the warranty period, not to last 300,000 miles in the real world. They optimize for fleet fuel economy averages while passing the long-term repair costs directly on to you, the owner. But now you know the mechanics behind the marketing. You know why your transmission fluid is cooking, why your battery is dying prematurely, and why your oil change interval is a ticking time bomb. If this video opened your eyes to what is actually happening under your hood, hit that subscribe button right now because the dealership network spends millions making sure mechanics like me never get these truths out to the public. Share this with every F-150 owner you know who is still trusting factory intervals and factory software blindly. Stop letting corporate spreadsheets dictate how you maintain your truck. Take control of your maintenance, protect your investment, and I will see you in the next one.